Welcome, everyone. Glad you could join us today. In this session, we'll talk about a brand new service we are launching, which will change the way you do ETL with Databricks. Delta Live Tables is a new managed service, which makes it radically simple to build, deploy, and manage your ETL pipelines. Later in the session, I'm joined with Bryce Bartman from Shell, who's been an early user of Delta Live Tables and has given us invaluable advice as we have built and evolved this service over the last few months. So with that, let's dive right into Delta Live Tables. Now, most of you are familiar with Databricks' Lakehouse platform, right? At the heart of our platform is Delta Lake, right? Which is the data layer, which gives you all the benefits of a relational database, but with the economics of an open file-based store. Now, Delta Lake gives you all these benefits in terms of performance, in terms of transactionality, in terms of time travel, and it's a great data layer for multiple use cases and scenarios, being data engineering, data science, machine learning, and straight up analytics. Now, using those capabilities of Delta Lake, we wanted to make data engineering, the building and operating of your pipelines, a far more simpler than what we are used to today. So let's talk about why we started going down this path. Now, for most of you here, this is not it's a new thing. You're used to the pattern of building data pipelines within your data lake, right? You typically have these multiple zones in your data lakes. You start bring the data in, you have a raw layer, or we sometimes call the bronze layer, and then you do a series of transformations. You're cleaning your data, you're augmenting it, you're standardizing it in typically what's called a silver layer. And then finally, you build your business level aggregations. You add the friendly field names and just make it ready for consuming by different applications downstream. Now, all of this is really modeled as a pipeline, right? All the way from your source to the target. Now, the complexity that comes in Data Lake's solution is the fact that the kind of sources that are arriving are complex, meaning that first of all, you have a lot of volume of data that's arriving, and it comes from multiple systems. Of course, your relational databases bring a lot of initial load of data, you change data that's coming from your transactional systems, and then you get data that's coming from files, and these could be rapidly arriving files. They can come in batch or they could come in streaming mode, and all this data has to be processed. And compounding that is the structure of the data itself. Sometimes you get well-structured relational data, sometimes it is JSON files, and sometimes it's just unstructured data like images and sound files and things like that. Now, all of this needs to be handled properly within the data. Now, within this diagram, it looks simple enough, but if you actually start scaling it in the data lake, you very soon realize that now you have tons, if not dozens, if you have hundreds, if not thousands of tables that are built and managed in the data lake. Now, managing the whole process of your pipelines across all these hundreds of tables can become very tedious and very complex. And typically we have seen users hit problems like, hey, one of my jobs failed, right? What is the impact of that? Did my data arrive at the right time? Can the rest of the processing happen? Is the quality of the data correct? I mean, who's checked it? And then failure and recovery is another issue. If something stops in the middle of your flow, how do you actually manage it, right? And what is the downstream impact? And then lineage is another problem. So there are all of these things that come into the picture when you're actually thinking of managing enterprise level data pipelines for your entire organization. So the whole idea was like, what do we do to make this simple? So when we started talking to many of you, actually, data engineers, data analysts who were trying to get the data right and prepared for different applications, we came across like several set of questions and issues that were recurring. The first thing was users found it hard to maintain dependencies between tables. Now you might say that, yes, we can do that with third-party orchestration tools. Some of this can be done with an Airflow, but all these orchestration tools, they actually control the processes. They're a workflow kind of a solution, right? So they know process one ran and then the process two can run after that. But they don't actually know about the data that each step that process is actually touching, whether that was successful, how many rows got transmitted. So it's not really modeling a data flow, it's really just a control flow mechanism. And then there was this other issue of batch versus stream processing. A lot of times as your data volume grow, you want to switch to more stream-based processing, while initially you might have been doing batch or much more schedule way of processing data. Then the second set of problems were around data quality. Now, how do you monitor the quality of the data that is flowing through your pipelines? How do you actually understand the lineage of the data so the business users actually using the data can trust the data that they are consuming in the analytics, in their machine learning models, what have you? The third set of problems came around just observability and just having much better monitoring capabilities for those pipelines, right? Rather than just looking at whether the process has succeeded, users wanted to understand at a data level what is going on with the pipelines. And then they wanted the system to be much more robust, not just stop every time there's an error and require manual intervention to actually handle this problem. So the whole process of error handling and recovery is another issue that we found users were facing. So keeping all that in mind is what we built Delta Live Tables for. So Delta Live Tables is a managed service which runs your pipelines for you. You can very simply just declaratively give the logic that you want to apply to transform your data to ensure its quality, and Delta Live Tables takes that information and runs the pipelines for you. It also abstracts away a lot of the complexity you need in terms of monitoring, maintaining state, and all of those, and makes it very simple to build, run, and operate your pipelines. Now, we have added a ton of new functionality for Delta Live Tables, and it'll take us, take me at least a couple of hours to go through all of that. But I will just say, touch upon the most salient ones. And it's easier to think of them in like buckets, right? So we have built a set of functionalities and capabilities to actually make it simple to develop your data pipelines. And the second thing is around how can you monitor your data quality and enforce data quality in your pipelines. And the third thing is about how do we provide ability for you to scale your operations, be able to add new pipelines without having to increase the load and the administrative overhead of your ETL flows. So we'll talk about the features in each of these buckets, and then I'll give a little bit of a demo towards the end of it in terms of what it looks like when you actually deploy these pipelines. All right, so on the first section, we have made it much more simpler to actually specify this data flow through your lake, right? And the way we have done it is provided a very simple APIs, which allow you to chain your logic. So you have a set of transformation logic that you want to apply to your data as it flows from its source to the target. Along the way, you may actually persist tables. You may create a bronze table, you might create a silver table, you might create a gold table, but even without it, you might create temporary views along the way to simplify your logic as the data flows from the source to the target. So what we have done is allowed you to create these simple chains of transformations from your source to the target. Now we support all languages. It's in SQL, Python, Scala. So it's very easy for you to actually link together the dependencies between the tables. So for example, here you can see that you first create a temporary view on the raw, basically on the raw data that's driving. And then this view then feeds your bronze table. And that bronze table, it feeds a silver table. So now you've specified the dependency between these tables. Now you can let the Delta Live Tables make sure that ensures that the data flows in the right order. If there's an error or if there is an hiccup in your pipeline, it knows how to recover from it and make sure that the data is delivered once and only once. So you don't have to manage the dependencies between the tables, and Delta Live Tables manages all of this. So it makes it far more simpler in terms of expressing the dependencies between these tables. Now, another interesting thing we have done is before, when users used to specify your pipelines, you will probably start building your initial pipelines as a batch process, right? And then say, hey, it's enough if I process data once a day. And sometimes there may be some data that has to be processed in a much more faster fashion. In fact, it may be much more rapidly arriving. To do that, you might almost have to rethink how you've done your logic, right? But switching from batch to streaming can be complex. So we have abstracted all of that problems for you. So literally, if you want to switch processing data from a batch mode and a schedule mode to an always on continuous mode, all you need to do is set a configuration saying, hey, this pipeline runs in a continuous mode. Once you do that, Delta Live Tables make sure that it handles all of those data in a streaming mode. And you don't have to worry about it. You don't have to worry about checkpointing. You don't have to worry about recovery. All of that is hidden from you because Delta Live Tables handles all of that. Another interesting thing we have added is an ability to do either incremental or complete computation for each table. So most of the data that you process in the data lake, it's incremental, meaning that you only want the change records that are coming into the system to be read and processed because you've already processed the data through the days. You don't want to recompute everything. Now that's great for your initial part of your pipeline as the data is flowing through all the way maybe through even to silver tables where you're doing scalar processing. But maybe when you go to the gold table, you want to recompute all the aggregates that you have there. So you have a consistent view. So your dashboards are reflecting consistent data. So for that, you might do a complete computation, which means that that particular table will read all the data from the preceding table and recreate all the calculations. So now you can have part of your pipeline doing processing data incrementally, which is basically change data that's flowing through your pipe, and part of your pipeline will be doing complete computation, right? So it is very simple now to mix and match. Before it was tedious, you'll have to figure out how to do CDC processing and then completely rethink how you do a full processing, right? So this makes it far more simpler to specify. Then you can think of Delta Live Tables as literally a template, right? So you can then instantiate your pipeline with configurations. So using variables, you can take the same code that you have specified for your pipeline and make it dynamic. So in this particular example, you may be reading in one instance, you might be reading data from a different file. And in the second configuration, you can switch it using the same code, and you can now read it from a different source, right? So it makes your whole pipeline dynamic. It reduces the amount of code you need, and it makes it much more simpler to deploy the same code in multiple environments. Maybe it's dev, test, production. It becomes far more simpler to do it that way. Now, of course, some of you love notebooks out there. So we have full support for notebooks if you want to build your pipelines either in Scala, Python, or SQL using a notebook environment, and you have a UI to actually deploy and run these pipelines from there. Or you can build your Delta Live Table pipelines in your IDEs with local development, and you can deploy them into Databricks that way. So we give you complete flexibility how you want to do it in terms of development itself. All right, now let's switch to the second set of functionality that we've added. This is all around data quality. We have heard from many users that usually data quality is an afterthought. So you build your pipelines, all the data is being delivered, and then maybe it's a process that you run outside of your pipelines, which monitors the data in your tables. Maybe you do some checks occasionally to see whether the data meets the business requirements that you have. But rather than doing this as a separate process, what we wanted to do was we wanted to make this a key part of the pipeline itself, right? So Delta Live Tables has a capability called Delta Expectations. So where you can set the rule for your pipelines, right? So it's very simple actually. So you can set a constraint that says, hey, this data needs to meet this particular rule, and rule can be very simple. It can be as simple as any Boolean logic, as you can see here, or it can be arbitrarily complex. You can have user-defined functions. You can have these rules in external tables, and you'll be able to dynamically apply these rules as the data is flowing through your pipeline. Now, if any record does not meet one of the rules you've specified, out of the box, we provide you with error handling policies. Now, these error handling policies include like fail, meaning to stop the pipeline if this is a serious error, if you can drop the record before it hits the target table, or eventually we'll also support quarantining the record, which is coming a little ways down the road. Now, in doing all of this, it's tracking the metrics for your quality tests. So as each row goes, we know how many rules are being met, how many are failing, and we're capturing all of this information into what we call the event log table. Now you can either look at the quality scores of your pipeline either through the UI for Delta Live Tables, as you can see here, or since this is just a Delta table, we are capturing all these metrics. You can build and your own dashboards, your quality dashboards, if you may, and see how the data is performing over time, whether the quality of your data is improving or decreasing over time. And this information can be used for building your own dashboards that you can show to your business users in terms of the trust of the data, in terms of how much, what the quality rules have been met and what haven't been met. Right? So it gives you far better visibility into your data quality of the data. And some of you may want to integrate this with catalog tools like Libra in terms of surfacing this for the business objects that you may be most concerned about. The other thing we've heard often is lineage, understanding where data comes for a particular table, as also to figure out impact analysis, right? If you have a change in schema or your initial source table changes, you'd like to understand what is the downstream impact of it. So now the lineage is, because of the way you've specified the Delta Live tables, the lineage is inherent there, and it's high quality, high fidelity lineage. So you can be sure that you understand all the downstream impact of a particular table or a field. And so that's visible to you. You can either use our own UIs that we have for Delta Live tables to get a good sense of the flow of data within your pipeline. But also, just like we did with data quality scores, we capture this lineage information in a table. So all you have to do is you can do a select statement and just get the lineage for any particular table, right? You can look at a target table, understand the source, and vice versa. So you get this lineage is available to you at your fingertips. Now, if you want to take this lineage, put in your own catalog, that's simple enough to do. So now you can have your enterprise-wide lineage if you'd like to then inspect how your data is flowing throughout your environment. Well, let's talk about the third set of functionality, which is all about the operating of this pipeline. Right? So there are several key things, and this is where a lot of the benefits of Delta Live Tables comes in, because Delta Live Tables is a service to run your pipeline. So it is inherently looking at and managing your pipelines and making sure they're running smoothly and correctly. So what happens here is once you deploy your pipeline, the service kicks in, making sure the pipeline is up all the time. If there are any errors, it has automatic error handling. We have several levels of error handling built in, so a lot of retry. 9 out of 10 times, the errors that you hit with your pipelines are transitory. They are temporary, and they can, once you retry, they're fixed. Not all the errors, of course, but majority of them. So Delta Live Tables already does all the automatic error handling for you, reducing the time you have to go to respond to broken pipelines or trying to fix them manually. The other thing we have also added is an ability to replay the logic of your pipeline. Many times you have to change the transformations you're doing. Maybe there's a different calculation you want to apply to the data as it flows through the pipeline. Now it makes it very simple. All you do is with literally a one click, you deploy the new version of your pipeline, and then you can do what is called a full refresh. So you can rerun the entire pipeline with all the data from the source. So all the tables along the way gets recomputed if you want them to get recomputed. If the formula is affecting certain tables, you can just recompute those tables alone and not the entire set of tables when you're in your pipeline. But now it makes it simple for you to deploy and reprocess parts of your pipeline without then trying to manually figure out which tables need to be reprocessed and which tables are just fine to be left as it is, even after the logic changes. So it really makes it far more simpler to do reprocessing, to do error handling, and just maintenance of the pipelines itself. Another key thing we've added is now Delta Live Tables is built on Delta Tables, obviously. So one of the advantages you get with that is Delta Live Tables has a full understanding of the tables and how they're being updated and how often the data is coming through. So it's able to do a lot of optimizations itself. Sometimes today you might be using, you might be running auto optimize you might set auto optimize on a table, or you might be collapsing the table, you might be optimizing it on a schedule. So you don't have to do all of that anymore, because Delta Live Tables eliminates all of that and automatically optimizes and tunes the tables for performance, right? And you of course can set additional Z order indexing on it if you'd like to. But the idea is that we want to remove that complexity from having to tune and manage your Delta Live tables by the system. It takes care of it from that point of view. Okay. Finally, probably the most important thing is the observability that you get of the operations of your pipeline. So now you get to get a sense of how the pipeline is behaving at a row by row level, right? In terms of how many rows have been processed, what's the throughput of the pipeline. You get a good sense of all of that. Before, there used to be a black box in a way, right? In terms of understanding how the data is flowing through your pipeline. You'd probably know whether the whole process succeeded or not, but now you get at a row by row level, you get to see how the transforms are working, which tables have been updated, how long it has been since the last update. You understand the throughput, and you can track your performance over time as the data is evolving. Okay. So there's just an incredible amount of benefit that you get in terms of manageability and observability with Delta Live tables. Right. With that in mind, let me just do a very short demo to give you a sense of what it looks like within Databricks itself. All right, here's a very simple SQL-based pipeline. We had a little bit of a code snippet in the files itself, but as you can see here, what you're doing is really creating a set of tables and views, and you're linking those tables and views together by referring to each other, right? So in this particular case, we are creating a view on customers and orders, simple enough. And then you're creating intermediate tables where you're joining your stores and customers, and then you're branching it out to both in terms of different tables in your goal layer where you are actually doing additional processing and transformation. So it's very simple now. Once you've specified it this way in your notebook or your IDE, you can just switch into the pipelines tab here, and you can just go ahead and do a create pipeline. Give it a name that's trivial enough there. So choose a particular pipeline, and you can say create, and it goes off and creates the pipeline for you. And while it's creating it, here's one that I've already deployed. And this is what it looks like once it's deployed. You can get to see the structure of your pipelines, the tables it's reading from, the joins that are happening, and the final target tables that is created. So you have a good sense of your entire pipeline in terms of the tables involved and the dependencies of the table itself. Now if you look at a slightly more complicated pipeline, for example, here's a pipeline that is written in Python. And again, the same process holds. You're creating product master and customer master in this particular case, which are both views. And then you can go ahead and join those, do the transformations that you want, your filters, your data quality checks, what have you. And then when you deploy it, you again get to see the behavior of the pipeline. In this particular case, it's running. You can go and get to see it here, and you can see your entire flow, and can get arbitrarily complex. And by the way, you don't even have to link all of this together into a single pipeline. You might have independent flows within the same pipeline that you might want to take a look at. Okay? All right. So, and the other thing is you can configure as we are talking about how you can configure and customize your pipeline, you can set a lot of your parameters here, and you can, change the way the pipeline behaves by setting the parameters out here. Now, in this particular case, as you can see, we have set the continuous flag to false. So it's a batch pipeline. So it'll read all the data from a source, and then when it's finished, it shuts down. So it's not always up and running. A different kind of a pipeline is here, for example. This is a slightly more complicated version of it. Here we're reading from a Kinesis source. Now, when I'm talking about a Kinesis source, it's always up, so that it's a continuously processing pipeline. You can see the data flowing through it. If you look at the settings, you will see that it is a continuously operating pipeline. It's always streaming, picking up the data from your Kinesis source, transforming and applying it. You can set a whole bunch of parameters in it if you want to. Right now, you get to set the compute, but the whole idea is down the road, we will abstract all of that away. So you don't have to worry about the compute. It'll be a so it's something the pipelines itself based on the history of the data, know what kind of compute to use and how to auto scale and all of that, right? So it makes it far more simple. Now, if you go back into the graph here, since it's a continuously running pipeline, I have all the statistics available to me. So I can click on it. Of course, I see the schema of the table, but I can also see the streaming, the stream that is running. You can see it's processing the rows, how long it took to process the last set of rows in this particular system. Now you can get the same visibility into different streams here. For example, if you go to the Delta operations table that we are looking at here, you will see that there is actually a data quality rule assigned to it, right? Which shows that 90% of the records that pass through this particular table, that arrive in this table, meet the quality rules. And if you want, you can click on it. You can see the details of that particular, quality scores that have been set, quality rules that have been set on that particular table. So in this particular case, we got 3 rules, basic rules that we're just checking for nulls in this particular instance. But you get a good sense of how good your data is as it is flowing through to that particular target table. You still have 9% of the data didn't meet those rules, so you might be able to take corrective action. Now, as I mentioned, most important thing for us was to make all this statistics, all the operational metadata of your pipelines easily available. Now, all of this is it's just stored in a Delta table. You can write your own queries, your dashboards, and you can write your own select statements, and you can set your own alerts. If you use SQL Analytics, you can go ahead and set your alerts in terms of like, hey, I'm expecting the data processing take a few minutes, if not, raise an alert. So you can build your own monitoring system on top of it, or export it out to any system that you may already have. And you can also look at the quality rules, scores. You can, analyze it, so you have a much better sense of how the data is processing and proceeding through your pipeline, right? In addition to data quality, you can also see your operational metrics here. So in a way, you get the level of visibility that it was impossible to get beforehand. All right. In summary, basically, Delta Life Tables, think of like, just imagine a completely different way of doing ETL. It's a much more simpler, easier way to do it. Development is far less complicated than it was before in terms of how you specify and how do you handle errors and how to recover. You got built-in data quality, and finally, you got a lot better observability, manageability, and error handling that Delta Life Tables provide out of the box. So with that, let me actually turn it over to Bryce from Shell. Bryce has been a great user of Delta Life Tables. He's given us a lot of feedback over the months in terms of meeting their use cases scenarios. So Bryce, I'd love to hand this over to you to talk about both Shell and your experiences with Delta Life Tables.
Great, thanks, Awais, and thanks for introducing me. So as Awais said, I'm Bryce Bartman, Principal AI Engineer in Shell's data science organization. And I want to talk a little bit today about intelligent pipelining of data, some of the challenges that we face as an organization to ingest large amounts of data, and how we are using Delta Live Tables to solve some of those problems. As you are probably quite aware, we are in the midst of rapid change in the energy business. Where we are facing not only a transition from hydrocarbon fuels into new energies, but also digitalization is having a large impact on that. And so today I want to talk a little bit about our journey and what Shell is doing in this space and how we're working with Databricks to solve some of these problems. Just as a cautionary note, some of the things I'm about to say are forward-looking. Please treat them with caution. And just something that we need to make sure that you're aware of as part of any of our communications. All right, so let's get into it. The pace of digital adoption is dramatically increasing at Shell. We are on a journey to move into the digital space, and we've been investing very heavily in this space in terms of resources and people and processes. And we are making strides in this area, and some examples of what we are starting to achieve. In 2020, we had 63 AI-powered applications. We are also ingesting vast amounts of sensor data from our assets, up to date about 1.6 trillion events are being ingested. We have 6,000 pieces of equipment that are being monitored using AI. We've done 1,200 and over drone missions. We have robots capturing video footage around our assets. And we're seeing a 10x increase in uses of virtual rooms due to COVID. We have 1.5 million registered users of our Go Plus application, our loyalty scheme. And we are also making big strides in terms of investing in people at Shell. We have over 350 people in our digital center of excellence. We have around 800 citizen data scientists that are working at Shell. And so we're on a journey, and we are making great strides. And we have a number of use cases at Shell and scenarios where data is making a big impact. So let's talk about a few of them. So digitalization and AI is driving efficiency across a number of our businesses. We use proactive technical monitoring to deliver around $130 million of value to the business through finding small and fixing small. We are now supplementing this with AI, and we have a predictive maintenance program that is using that large amounts of event data that I mentioned earlier, about 1.6 trillion data points, to be used in machine learning models to detect anomalies in our data. We also have real-time use cases. So could we start optimizing some of our production in real time, looking at real-time feeds coming from our assets? And we've deployed the real-time production optimization application that is deployed at our liquid natural gas sites. And it's achieving 1% to 2% production increases. At the same time, also reducing some of our CO2 emissions. And then another example is digital twins. So what digital twin achieves is it creates virtual environments of our real assets. These are data hungry applications. We've partnered with Kongsberg on this, and we need to pipeline vast amounts of data for each asset into the digital twin to make it useful. For example, we need to ingest sensor data, hundreds of thousands of sensors. Typically, we need to ingest video footage, audio footage, drawings, anything to make that virtual reality more meaningful and more a representation of real life. And we've rolled this out to one of our plants in Nyamna, and we've got 5 other assets that we're looking at deploying in 2021. So in our existing business, there is a lot of work that we need to do to deliver the data to these applications. Additionally, we also need to look at the next generation of clean energy and where we're going with that. Shell offers customers over 165,000 charge points around the world, and it makes Shell one of the largest electric transport solutions in the world. That generates large amounts of data, and we're using that to try and optimize how vehicles are charged by understanding and learning people's interactions with these points. How can we make it more efficient for the user? And how can we also protect the grid at the same time by making sure we deploy the energy in places where it needs to be at the optimal time? Additionally, we also are investing and working very hard on how we can start leveraging hydrogen more efficiently in the energy transition. Our projects include developing methods of production, storage, and transportation, and converting existing industries such as cement and steel industries to start using more clean energy is complex. In order to do this, we can't just try out every type of scenario in the real world. And so we're using data to build data-driven simulation models combined with physics-based models to optimize traditional experimentation. And lastly, we are also doing a lot of work around using data in wind farms. Building wind farms is complex. How we do it and where we build it and how we should set that all up can be optimized. And so we're using data and AI to calculate how to do all of that. Now, to achieve all of this, we've obviously built out a capability within Shell. We're very proud of what we have done in terms of AI and data science. But we obviously cannot do any of this without working with our partners. And here, this is why I'm talking to you today, is because we've been working really closely with Databricks. And as Wes mentioned, I've also been an early user of Delta Live Tables. And I want to talk a little bit about, the challenges that we face as an organization to deliver data for all of these kinds of applications that I've just mentioned, but also what we need in terms of building production-grade pipelines that we can deploy around the world at scale, and deliver everything that we need from one corner of the globe to the other. So let's talk about what I consider some of the data pipelining key requirements we need to achieve. Firstly, connectors. So we need to be able to connect to vast types of data sources, whether it's a file system, databases, APIs, streaming sources in the pub/sub kind of domain, cross-cloud. We need to be able to connect to as many data sources as we can, and as well as being able to write to different locations. Secondly, we need transformation and AI as part of our data pipelines. We need to be able to perform simple and complex transformations on the data. But additionally, what is very important these days is to start factoring in AI into your data ingestion. Could you do things like face detection to conform to legal requirements? Could you do anything like machine learning on the fly or anomaly detection while you're ingesting data? These are all becoming important features of what we're developing at Shell. Quality. We need to make sure that we can be confident in the data that we're looking at. Do we know the standards of the data that we've got, or are we just ingesting whatever we're receiving? Could we control it, quarantine it, or even drop it if we don't need it? Recovery is also really important. When we deploy pipelines at scale, we want to make sure that it can recover automatically. When we're thinking about a pipeline that is running across the globe, we need to make sure that we don't have manual interventions to restart. So recovery is really important. And in a similar vein, scale needs to happen as quickly as it is needed. We may go through periods where there is low demand on some of our pipelines, and we want to use elasticity in the cloud to reduce our cost where we can. But we also want to scale up where we need to achieve some of the SLAs that we have around our data. And finally, monitoring. We want to be able to make sure that we have a good picture as to what is going on in our pipelines. One of the things that is often really useful from a streaming pipeline is for it to alert you when it's seeing numbers that are much lower than expected. We also want to be able to identify where we are seeing challenges with performance, and what the metrics are around all of these pipelines. So in my eyes, these are the 6 kind of key features or requirements that we need to build production-grade, fault-resilient pipelines in Shell. So with that, when Databricks pitched the idea of Delta Lives tables to me back a while ago, I was really excited to see that it was tackling some of these problems. So let's talk about Delta Live tables and what I see as the kind of key features of it that make it really exciting for us to use at Shell. So it's code-driven. We have found that if you want to build production-grade pipelines and need to take into account all 6 of the kind of key requirements I mentioned earlier, they are not simple. They start off simple, but they don't finish simple. They get complex and they have a lot of functionality that they need to achieve. They need to be sending metrics to certain locations. They need to be doing transformations. They may even be needing to send the data off to a separate vendor at some point and come back and carry on. So we really like the idea of code-driven Delta Live tables using Spark as the languages. It also, we've seen that has driven much better kind of software engineering standard around how we build our pipelines. Secondly, Spark is obviously a great language to be using for building data pipelines and in this case, Delta Live tables. Spark has obviously got many built-in transformations that we can use. It's also got scale. The connectors that we find in Spark are great. And so it's a very good language for what we want to achieve. Thirdly, it's Delta-centric. So as Awais mentioned a little bit earlier, we find that developers often like to write their data into Delta, but they forget the small things that actually become very significant when it comes down to performance. Am I running optimize on my tables? Have I vacuumed my tables? Have I thought about Z ordering? what Delta Lab Tables does is brings all of that into the thought process of our developers. And so the maintenance jobs that get automatically scheduled by Delta Lab Tables to perform all of those tasks is actually key to making sure that your Delta Lab Tables perform as you expect it to. As the way it's also demonstrated, the UI monitoring is really useful for us, being able to depict how our data and its lineage is formed and how the data is flowing through each of those points is really useful information to us. We get to see what the performance is, how many rows we're expecting to flow through the system. And so that's really a key component that we've been missing up until now that we really like about Delta Lab Tables. Lakehouse. One of the big steps, and I'm sure you will be hearing many of the kind of innovations going around Delta, is the Lakehouse environment. What we like most about Delta is that it gives our data lake, data warehouse kind of capabilities. The more times we move data between different storage components in a pipeline, the more faults we introduce into the pipeline itself. If we can reduce the amount of hops that data is doing, the more accurate and more reliable we find our pipelines to be. Lakehouse achieves this by making sure that we don't move data between different data storage components just for the sake of needing to do so. Aggregating data in another storage component doesn't really need to happen anymore when we start looking at Lakehouse. SQL endpoints is obviously the other component that makes Lakehouse a very attractive option. Gives us the compute to query all of this data we're writing into Delta and showing it in tools like Power BI and other BI tools that you can use. And lastly, the innovation. What we've really enjoyed about Delta Lab Tables is how Databricks has engaged with Shell to build out the capabilities. At all points and literally on a weekly basis, we've been working with with Databricks and the Delta Lab Tables product team to explain how we're using Delta Lab Tables, what we like about it, what we think needs to be improved, and what we want to see in the future. We also see that the benefit of doing this is providing Databricks with real-world scenarios of how we use Delta Lab Tables and how even our development teams and the organizations that they work in and how they would use Delta Lab Tables in those scenarios. Some of the examples of where we've deployed Delta Lab Tables at Shell is by ingesting IoT sensor data directly from the cloud or from 4G, 5G signals into Delta, and automatically we've also built on top of it SQL endpoints so that people can query that data and view it in real time. Another one is that we've actually started ingesting video feeds from some of our assets and using Delta Lab Tables and some intelligence to do facial detection on that video before we store it in our data lake. So we've been having a great experience with Delta Lab Tables, and I wanted to also just give some highlights as to some of the benefits that Shell is seeing in terms of using Delta Lab Tables. Some of our developers are calling it the new gold standard for data pipelines. Delta Lab Tables makes it easier for us to build intelligence into our data ingestion processes. Having PySpark as part of your Delta Lab Table opens up all the opportunity around the ML kind of libraries that you have in PySpark, that you can actually start thinking about intelligence as part of your ingestion process. Delta maintenance tasks are no longer an afterthought for developers. So like I mentioned, it automatically sets up your maintenance job and it runs it on a daily basis for you, performing all the kinds of tasks to keep the Delta Lab Table performing properly. And expectations has obviously been a very good feature that we've enjoyed seeing included in Delta Lab Tables. And some people are saying that they're starting to be able to trust their data more because of what expectations brings to their pipelines. So in all, we're really excited about what we're seeing with Delta Lab Tables. We've really enjoyed working with Databricks on it. And we look forward to all of the kind of new functionality that is coming on the roadmap and to deploying more Delta Lab Tables at Shell. So back to you, Awais.
Thank you, Bryce. It's been a great pleasure working with you, collaborating with you. Thank you for all the input you've given us, and glad that all that the input that you've given us actually helped us make this product, I think, very suitable for both Shell and hopefully for many other customers in the audience today. Thank you, everyone, for joining us. for taking the time to learn about our exciting new service that we're launching. We hope to be working with many of you as you start trying out Delta Live Tables going forward.